This is shuttle launch control at T-minus 4 hours, 43 minutes and counting. All continuing to go well in our tanking operation with the shuttle Discovery getting ready for the STS-41 launch. 7:35 a.m. Eastern Time this morning. Discovery is carrying the Ulysses payload and several mid-deck experiments. This is shuttle launch control at T-minus 3 hours and holding. We're joining the flight crew for STS-41 in the crew quarters. This mission specialist Bruce Melnick. He's making his first flight today aboard the shuttle Discovery. Pilot Robert Cabana. Commander Dick Richards. Mission Specialist Tom Akers. Mission Specialist Bill Shepard. He's making his second flight aboard the shuttle Discovery today. We do have live coverage of the flight crew donning their launch and entry suits. Got Commander Richards being assisted with the gloves. Pilot Robert Cabana is now putting his gloves on. Mission Specialist Bruce Melnick giving a thumbs up. There's Mission Specialist Bill Shepard. He's making his second flight into space today. And Mission Specialist Tom Akers. He's making his first flight aboard the shuttle today. Closeout crew is busy preparing the crew cabin for the flight crew's entry. Here we have the ground floor of the operations and checkout building. The flight crew now coming out, being wished a good flight by employees here at Kennedy Space Center. Pilot Cabana, Bruce Melnick, Bill Shepard, and Tom Akers. Getting on board the astronaut van. This is the traditional method of transportation for the flight crew out to the launch pad. The crew members are boarding the orbiter.
Yeah, 2017 GMT.
Being assisted right now is Commander Dick Richards. He's the commander of the flight today. He's now climbing aboard and will be getting strapped into his seat shortly. Pilot Robert Cabana is now being assisted by members of the closeout crew with the final items of the gear he will need for launch today. He's a lieutenant colonel in the United States Marine Corps. He was born in Minneapolis, Minnesota. He was selected as a NASA astronaut in 1985 and is making his first trip aboard the space shuttle today. Mission Specialist Tom Akers is being assisted with his equipment now to get into Discovery's crew cabin. He is making his first trip into space today aboard the shuttle Discovery. And the closeout crew is now assisting Mission Specialist Bruce Melnick with the rest of his flight crew equipment. Melnick is a commander in the United States Coast Guard. He was born in New York City, but considers Clearwater, Florida to be his hometown. Mission Specialist William Shepard is now being assisted with the equipment he will wear aboard the orbiter Discovery for the ascent portion of the flight.
ISO is open, the talkback reads open.
And the vent talkback is closed.
At this time, the hatch is being closed out for flight, and the crew has been directed to begin cabin leak checks. This is a routine operation in the final hours of the launch countdown.
PTC entity. Go ahead, sir. Okay, we're expecting a momentary go here, and just re-verifying with you again that you are go. Yes, sir, we're go. Understand, thank you.
Entity Flight 212.
Go ahead.
Okay, we've taken a look at this rain shower, and we're going to clear this one, and we're go.
Understand, launch director? Copy, go to proceed. Understand. Launch team, we're going to pick up the count at T-minus 9 minutes momentarily. PLS, pick up the count on your mark. Normal pre-start. Normal pre-start, I copy. If you copy momentary hold, 5 minutes. That's firm. Okay.
PLS, let's go for OAA retract.
And we have a go for retracting the orbiter crew access arm away from the vehicle to the launch configuration.
HCD go. Yeah. 1066.
Entity Flight.
Go ahead, flight.
SPCs are on board.
Copy. And CDR, did you copy? We'll have a momentary hold at T-minus 5.
CDR copies.
Coming up on T-minus 4 minutes and counting. APUs have been started and the orbiter heaters have been turned on for launch.
PLS, let's go for purge sequence 4.
A final purge of the main engines is underway to prepare the engines for start. At the 1 minute point in the count, an engine ready indication will be given. Retraction of the gaseous oxygen vent hood is now underway. Just a few minutes away now from the launch of Discovery on a 4-day mission with 5 crew members, coming up on the T-minus 2 minute mark.
OTC, PLT, caution, warning, clear.
Copy that. And flight crew OTC, close and lock visors, initiate O2 flow, and have a good flight.
T-minus 31 seconds. We have a go for auto sequence start.
25 seconds.
Discovery's 4 redundant computers have primary control of critical vehicle functions. T-minus 15 seconds. T-minus 10, 9. We have a go for main engine start. 6, 5, 4, 3, 2, 1. Ignition and liftoff of Discovery and the Ulysses spacecraft bound for the polar regions of the sun.
Roll program, Houston.
Roger, roll, Discovery.
This is Mission Control. The roll maneuver puts Discovery into the correct launch plane. Guidance officer confirms a good roll maneuver. Engines now throttling down in preparation for Discovery's passage through the maximum aerodynamic loads area. Auxiliary power units, all 3 looking good. Discovery's velocity now 2,300 feet per second.
Discovery, go at throttle up.
Go at throttle up.
The go at throttle up call means that everything is working well aboard Discovery. All engines now back at 104% performance. Velocity is now 3,300 feet per second. Discovery now 14 nautical miles downrange from Kennedy at a velocity of 5,000 feet per second. And we have separation of the solid rocket boosters. velocity now 5,400 feet per second. Discovery 31 nautical miles downrange. Auxiliary power units still performing well. All 3 engines at 104%. No systems problems aboard Discovery.
Discovery, performance nominal.
Nominal performance.
This is Mission Control, Houston.
Discovery, Houston, you gotta go for payload bay door ops.
Okay, go for payload bay door ops.
That's correct.
Crew has just been given the go for payload bay door operations. They will begin opening the payload bay doors aboard Discovery, and we'll be standing by for a status on that in the next few minutes. This is Mission Control. This is Mission Control.
Open and everything was no motor time.
Roger.
The crew confirms the payload bay doors were open and the motors drove properly. Max officer had given that confirmation just a couple of moments earlier.
Discovery, you gotta go for orbit ops.
Roger, go for orbit ops, thanks.
And Houston Discovery, state vector transfer complete at 5 hours, 23 minutes, 10 seconds. Getting ready to release perlas and raise to 29.
Okay, we copy, Tom.
And the crew reporting that they're about to move into the release of the payload retention latches and the elevation of the tilt table to 29 degrees. With one motor operating, the nominal time for that to take place is about 40 seconds, and with 2 motors going, the tilt table will go up to 29 degrees in about 20 seconds. So we'll stand by for word on that. Tilt table raises up in 2 stages, first to 29 degrees and then to the deploy elevation of 58 degrees.
We've just dropped the umbilicals and raising to 58.
Yep, that's what we're seeing.
Okay, they look okay?
Yes, sir.
Thank you.
Okay, thanks.
Capcom, we are go for deploy.
And Discovery Houston, you are go for deploy.
Copy, go for deploy, KT, and we are at 29 degrees. The time to raise was 3 minutes, 40 seconds, and you can see we're on internal power, and Perla release was dual motor time.
Okay, we copy all that, Tom. That's good news.
"30 seconds to deploy, flight controllers."
Okay, Tom, I'm gonna have to move right into there when this thing starts getting up a little bit. We'll get there. Hold on a second.
Now standing by for confirmation of deploy.
Good deploy, Houston. Ulysses is on its way.
That's a great job.
Deploy of Ulysses took place right on time, 6 hours and 59 seconds into the flight. That's off 1 second from the pre-mission prediction for the nominal time, so that's pretty good pointing.
Discovery Houston, for your information, Guam ground station has picked up the Ulysses spacecraft just where they thought it ought to be.
Fantastic.
You guys did a good job.
The crew winding down after a long day. Mission Control sent them to bed with a couple of final housekeeping details, and barring anything that comes up in the next hour or so, we don't intend to talk to them. We'll let them get some sleep and enjoy the view out the window.
This is Mission Control. Discovery is just about to cross the eastern coast of Australia, going out across the Great Barrier Reef on the final part of the descending node of Orbit 12.
Discovery Houston, good morning.
Houston Discovery, good morning. Okay, KT, now we'll show a little bit of today's activities. Tom and I had to participate in DSO 602, and this will be a little sequence that we took of us getting instrumented up with electrodes this morning, and we decided to run this for all the ladies down there in Mission Control.
Okay, we are waiting breathlessly.
And what they're doing now is setting this thing up to park it for the Intelsat Solar Array Coupon experiment that we're doing with an eye to the mission next year to go after the Intelsat satellite that was stranded in low Earth orbit earlier this year. The idea is to study some of the same materials that are on the Intelsat and get a view of the kind of degradation from ionized particles near Earth that satellite might experience. The graphics we're seeing here again produced by telemetry coming down from Discovery, and after they pass through the computer system here on the ground, show up on this screen in Mission Control at the PDRS console.
Flight PDRS.
Good.
Yeah, they've completed the ISAC park procedure.
We're now parked.
Parked. We're having those atoms ram into that witness plate as we speak.
Houston Discovery with some arm notes.
Okay, Shep, we're listening.
Isaac is parked, and it looks like we had a 13-second backup payload release, but everything else, including the snares, looks fine.
Okay, thanks, Shep.
Now we're going to move on to SSCE, and here's what we recorded on board with a fiberscope just a few minutes ago.
Okay, we're looking.
And Tom says this is the side view, or camera number 2's view of the SSCE event.
Okay, we copy that.
Discovery now passing out over the coast of South America. Actually, this looks like Brazil, out over the southern Atlantic now.
Following completion of this SSBUV solar view data take, crew will begin to perform the calibration, a number of calibrations throughout the flight, both in the early phases of SSBUV data takes and in the middle of the process of the data takes, and then late in the flight also. The SSBUV instruments are calibrated to assure the accuracy of the measurements taken both in the direct sun pointing and as well as the backscatter measurements from the Earth's atmosphere. That particular process will take just about 45 to 50 minutes.
This is Mission Control. Discovery is now over the South Pacific, seeing one of its many sunsets. The crew currently has about 4 hours and 35 minutes left in their sleep period. And all remains to go quite smoothly here in the flight control room as controllers prepare the messages for uplink to the crew later.
Good morning, Discovery.
Good morning, Houston.
Good morning, Dick.
STS up here for the last several days in space, and we thought you'd like to see how it's been working for us. George Salazar and his crew down there at the Johnson Space Center have put together a system that allows us to control the cameras without using our hands. We can just use voice commands to talk to the cameras. So here's a quick demonstration on how they work. Voice command, activate.
Select the monitor, then a camera.
TV1, Delta. Action.
Action.
Right. Stop. Tilt up. Left. Stop. Right. Stop. Change rate. Tilt down. Stop. Change rate. Tilt down. Stop. Right. Stop. Too much. Too much. Too much. Zoom in. As you can see, it's a great system, and we really like it.
Meet the latest NASA computer.
Ready to activate.
NASA engineers have come up with a computer now on board Discovery. It's a computer that talks and listens and controls the shuttle's television cameras. Chris Gerhardt is one of the engineers who designed the computer to respond to commands from the human voice.
We think this is going to be useful to the astronauts for two reasons. And the first reason is that by having a system which is voice controlled, the astronauts' hands and eyes are free to perform other tasks. The second reason is that by using a voice controlled system, it isn't necessary for you to be in the location where the system is in order to control it, so you're free to move around and you can be remotely located.
The system is in the orbiter's aft flight deck, and it's very easy to operate. With a flip of a switch, the system is ready to go, and that's the only time the astronaut will use his hands. The computer actually tells the astronaut what to do next by using this monitor. STS-41 mission specialists Bill Shepard and Bruce Melnick will be using the system for 20 minutes each during 3 flight days. They tell the computer to move the camera in the payload bay. The astronauts use this mock-up at the Johnson Space Center to learn how to use the system.
Right. Change rate. Stop. Change rate. Up.
Melnick and Shepard began training on the system last spring.
Training consists of going through our vocabulary list 2 times and saying each word.
The vocabulary is made up of 40 simple words the astronauts use to control the cameras. Words like zoom in, zoom out, tilt up, and tilt down.
Now, they did tailor their vocabulary to their personal use. Words that they were the most comfortable with, words that worked the best for them. So both of our astronauts have a different vocabulary, but they're also very similar, and they're the words that make sense to them.
The computer had to learn to understand those words. That's done by first letting the astronauts read a list of commands.
Each word is then digitized and stored in memory as a template or voice print similar to a person's thumbprint. And then all those words are then saved according to each person as their templates.
To work right, the astronaut's voice must match the one the computer remembers. Sounds simple here on Earth, but up in space, it could be a problem.
We do know that in zero gravity, that the position and the shape of the lungs and diaphragm are altered. Now, if this causes a great enough distortion in the voice, good recognition could be difficult to get. So we're expecting that this may be a problem.
So the astronauts can make a new set of templates in a matter of minutes if their voice is altered in space. Gerhards, Summers, and project manager George Salazar are excited about the future applications of this voice-activated technology.
There are several successful applications of voice command systems in the commercial sector. Aid for the handicapped, for example, where a handicapped person can use voice recognition technology to control a motorized wheelchair.
And how does it feel to see their project literally take off?
It feels so fabulous. You know, there's times when you really think it isn't going to fly. It's not going to go. And now not only is it going to go, but our astronauts love it. They love it. They're having fun with it. Everybody we've shown it to likes it. People are coming up out of the corners with ideas of how to use it. And it really makes you feel like you've accomplished a lot.
And KT IPMP is a materials experiment that we were activating that's going to investigate the characteristics of polymer membranes or filters formed in microgravity.
Crew aboard the vehicle will begin test objective 1206, which is the cursor control device evaluation. Bill Shepard, mission specialist number 2, will be evaluating a cursor control device that has the potential of affecting design of cursor control devices for a crew computer workstation aboard the space station.
Okay, you should have a picture of Bob sitting in front of one of our DTOs. This is DTO 1206, which is entitled the Cursor Control Evaluation. In a way of an explanation of it, the space station is looking towards using this particular computer, which is a Macintosh version, onboard space station, sort of like our version of the grid computer, which we've used here for the last 10 years onboard the space shuttle. The system uses a different type of human interface, as most people familiar with the Mac know about. It uses a cursor control, and normally we use a mouse for that, as it's called. But on previous flights, we've determined that the mouse don't work so well in zero-G, so this time around we tried two different cursor control devices, as Bob is demonstrating right there. One is a trackball. This is the alternative pointing cursor control device that was provided to us. You just saw it. We'll get a close-up of it in a minute, but it's called a Felix, manufactured by a company out of beautiful Laramie, Wyoming. And it's a little bit different in as it doesn't use a trackball. It's more or less a standalone instrument that you can get away from the screen and move it. It gives you a little bit solid, firmer base. It's interesting, our reactions. We generally like the trackball in 1G, but almost the opinions have been reversed coming up here on orbit, at least our own qualitative opinions. We're going to be interested to see if the scoring system they provided to us reflects the qualitative observations. But you can see when we get rid of these discs, you're going to have to pay attention to where they go. And finally, for all of you down there and our families, if they can see it, that's all of us waving to you all for the great job you've done for us.
Okay, we're all waving back to you. Well, thanks for the playback. We are a couple minutes to LOS. We'll see you on the other side at 5:51.
We'll see you then, KT.
This is Mission Control Discovery, which is orbiting about 178 by 160 nautical miles. It is currently crossing Malaysia, heading into the South China Sea. This is Mission Control. We're at a mission elapsed time of 2 days, 11 hours, 55 minutes. The crew has just over 6 hours remaining in their sleep period. Currently, Discovery's payload bay cameras are once again catching some lightning activity as Discovery passes overhead. On previous nights, we've seen quite a bit of lightning activity.
Good morning, Discovery.
Good morning there, Story. This is some DSO-474 activity that retinal photography that Bob and Shep participated in on day 2.
Okay, we have a good picture.
Today's a special day for one of the members of our family, the wife of Mission Specialist 3, Tom Akers. Kay Akers, it's her 25th birthday today. And to mark that occasion, we don't have a birthday cake on board, as NASA doesn't let us start fires, except for Tom. He's the only one that's been able to start an authorized fire. He did that yesterday. But we don't have any other fires on board, so we had to come up with something special here for you, Kay. This is one of the fine bakery products provided by the NASA Bakery, and that right there is a Kim light poked in the middle of it, so it's the best we could do, but it's the thought that counts. And we also have an appropriate sign for you that says Happy Birthday, Kay. If you can't read that, we hope you can. And as the last special tribute to this, the Discovery Chorus will mark this occasion with a special serenade. Happy birthday
hour later.
This is Mission Control Houston at 2 days, 22 hours, 26 minutes. All quiet here in the flight control room as the crew aboard Discovery continues to work through their flight control systems checkout. That's a checkout to verify that all flight control systems aboard Discovery are in good health and ready to support deorbit entry and landing operations tomorrow. Discovery just about to cross the equator and begin the orbit number 48.
Okay, KT, we'll pick up with the RCS hot fire test if you're watching.
Yeah, we're watching for that.
This is Mission Control, all continuing to go smoothly in the checkout of Discovery's reaction control system jets. There's split-second visuals of the reaction control system jets as they are put through their paces and tested for tomorrow's entry and landing.
Meanwhile, aboard Discovery, this is a LIO canister changeout. These lithium hydroxide canisters are used to cleanse the breathing air, and that's part of the nightly routine before buttoning up the ship and getting ready for bed.
This is Mission Control. These pictures taken from Discovery at an altitude of about 162 nautical miles shows the Saudi Arabian Peninsula. In the lower right-hand corner of the screen, one can see a small circle. That is the hatch that leads in, that the astronauts go to and from the orbiter when they're down here on Earth. And the large panels extending up to the left-hand corner of the screen are the payload bay doors.
We're looking down on South America now. One has to presume that's the Andes. Discovery coming up on the coastline as we speak.
I was a sailor, I was born upon the tide. With the sea I did abide. I sailed a schooner around the Horn of Mexico. I went aloft to furl the mainsail in a blow. And when the yards broke off, they said that I got killed. But I'm living still.
Good morning, Discovery.
Morning, Story.
Good morning. We were not going to let you come home. Not going to let STS-41 come home without some country and western.
Yeah, we like both kinds of music, country and western.
Okay.
Flight control team here has declared themselves go for payload bay door closure.
Okay, copy the rad bypass and the FES checkout's normal, and we don't need the numbers, and you got to go to close the doors.
Okay, go to close the doors.
This is Mission Control Houston at 3 days, 22 hours, 35 minutes. Mechanical Systems Officer here in the control center, confirming that the motor drives are turning, then the payload bay doors are being driven to close. We're now 58 minutes and 30 seconds away from ignition of Discovery's twin orbital maneuvering system engines for the Deorbit Burn, the burn that will drop Discovery and crew out of orbit and begin the entry and landing phase of the flight.
Okay, that's great. And you've got to go for the Deorbit Burn.
Go for the burn. Thank you.
The Deorbit Burn should be underway about 22, 23 seconds into the burn.
Discovery Houston, we're back with you now on the west satellite. How's the burn?
Good burn, Brian. Well, we're maneuvering to the I-5 attitude.
This is Mission Control Houston. Discovery beginning to encounter the first effects of the Earth's atmosphere. Onboard navigation aids beginning to produce altitude data, showing Discovery at an altitude of 389,000 feet, traveling at Mach 24.4, and descending into the atmosphere at a rate of 518 feet per second. We're now taking live scenes on NASA Select Television of the Edwards Air Force Base area, as the sun has begun to illuminate the sky enough to see the landscape around. We're now taking our first live views of Discovery on our way to an Edwards landing. This is from the Vandenberg Long Range Tracker. All systems continuing to work well. Discovery right on the ground track.
GNC, you got the probes out? Yes, sir, we're evaluating. Flight guidance, go. We're go tack
Discovery, tack ends, look at that.
Take tack in.
Roger, Discovery, take tack in.
Okay, we'll take them.
Discovery Houston, like a state vector transfer to the BFS.
Okay, we'll get it.
Two sonic booms announcing Discovery's arrival overhead at the Edwards landing field. Discovery headed for the heading alignment cone. That's an imaginary cone down and around which the vehicle is maneuvered to set up the desired altitude, heading and airspeed for final approach and landing.
Go ahead. Looks good rolling onto the hack. No change to winds or weather.
Copy.
Discovery Houston, looking good on the hack. No change to the winds or weather.
Okay, Brian.
Discovery sinking at 174 feet per second. Discovery under manual control of Crew Commander Dick Richards, now performing the pre-flare maneuver, taking some of the steep angle out of the final approach. Landing gear down. Gear confirmed down and locked. Main gear on deck. And nose gear touchdown. Discovery rolling out on Edwards runway 22.
Wheel stop, Houston.
Copy, wheel stop, Discovery. Rest of your team's glad to have you back. Also to have the fastest man-made object in the universe well on its way. Congratulations on a picture-perfect mission, and there are no post-landing deltas.
Okay, Brian, no post-landing deltas.
Unofficial landing times are as follows. Main gear touchdown at 4 days, 2 hours, 10 minutes and 4 seconds. Nose gear down at 10 minutes and 16 seconds. Wheel stop 4 days, 2 hours, 10 minutes and 54 seconds. The STS-41 flight crew emerging from their spacecraft, and by the greetings of Chief Astronaut Dan Brandenstein, Director of Flight Crew Operations Don Putty, and Shuttle Chief Robert Crippen. I'll take a spin around the vehicle to take a look at the condition of their craft. After having flown 1,707,445 statute miles.